Alright, here's example number 4. So far in all the problems we've been doing, we've been working on the left side of the problem. But generally it's best if you work on the side that looks more complicated. And in this problem I would say that the right side of the problem definitely looks more complicated. So I'm going to work on that side instead. One of our hints was if we have a fraction we could get a common denominator and combine those fractions together. So that's what I'm going to try and do here. Okay, so this one, cosecant x minus 1, cosecant x plus 1, if I want a common denominator I need to multiply this fraction by this, and this fraction by this, correct? So let's do that. 1 times cosecant x plus 1 over cosecant x minus 1 times cosecant x plus 1. So I can multiply that on the top and the bottom because that would together equal 1, so I'm not changing the value of the problem. Now let's look at the other fraction. So this one's missing the other denominator, which is cosecant x minus 1. So we're going to multiply cosecant x minus 1 on the top and the bottom. Alright, let's go ahead and work this through. So cosecant x minus 1 over, now let's go ahead and FOIL this. So that will give us cosecant x squared x minus 1, right, because it's a difference of squares. This negative and positive outside inside will cancel. Okay. And then we're going to subtract cosecant x minus 1. Oh, and that should be a plus. Oops. Okay. The problem with not actually being in class to do this is I don't have you guys to help me catch my mistakes. Okay, so cosecant squared x minus 1, again, when we fill it out, we get the same denominator. That was our whole goal, right? Now we're going to distribute that negative through. So that will give us cosecant x plus 1 minus cosecant x plus 1, because we distribute the negative. Okay, so, and of course, that's over that same denominator, cosecant squared x minus 1. So now that, the cosecants cancel, and we just have 1 plus 1 is 2. Over cosecant squared x minus 1, and that stuff on the bottom is a Pythagorean identity that equals tangent. So therefore, we have 2 tangent squared x, and that matches the other side of our beginning problem. So we're done.